The Isotopes and Atomic Mass Simulation is an interactive educational tool designed to help students explore and understand the principles of isotopes, atomic mass, and the calculation of average atomic mass. By providing a hands-on approach to investigating the properties of isotopes and their mixtures, the simulation offers a comprehensive learning experience that covers fundamental concepts in chemistry. The simulation allows students to build isotopes, investigate their atomic mass, mass number, and relative abundance, create mixtures of isotopes, and compare their mixtures to actual isotopic compositions. Isotopes are variants of a chemical element that have the same number of protons but different numbers of neutrons. The Isotopes and Atomic Mass Simulation begins by introducing the concept of isotopes, explaining how they differ in their atomic mass and mass number due to the variation in the number of neutrons. The simulation provides an interactive platform where students can actively engage with the concept of isotopes. By building isotopes and adjusting the number of protons, neutrons, and electrons, students can observe how these changes affect the atomic mass, mass number, and relative abundance of the isotope. This hands-on approach helps students gain a deeper understanding of the principles governing isotopes. The Isotopes and Atomic Mass Simulation allows students to build isotopes by adjusting the number of protons, neutrons, and electrons. By changing the number of neutrons while keeping the number of protons constant, students can create different isotopes of the same element. This interactive feature helps students understand the relationship between the number of protons, neutrons, and the atomic mass and mass number of the isotope. Students can investigate the atomic mass and mass number of the isotopes they create. The atomic mass is the total mass of the isotope, including the mass of the protons, neutrons, and electrons. The mass number is the total number of protons and neutrons in the nucleus of the isotope. By observing these values, students can gain insights into the properties of isotopes and the factors that affect their mass. The simulation also allows students to investigate the relative abundance of isotopes. Relative abundance is the proportion of each isotope in a mixture of isotopes of the same element. By adjusting the relative abundance of different isotopes, students can observe how the average atomic mass of the mixture changes. This feature helps students understand the concept of relative abundance and its importance in determining the average atomic mass of an element. The Isotopes and Atomic Mass Simulation enables students to create mixtures of isotopes by combining different isotopes of the same element. By adjusting the relative abundance of each isotope in the mixture, students can observe how the average atomic mass of the mixture is calculated. This interactive feature helps students understand the principles of isotopic mixtures and the calculation of average atomic mass. Students can investigate how the average atomic mass of a mixture of isotopes is calculated. The average atomic mass is the weighted average of the atomic masses of the isotopes in the mixture, taking into account their relative abundance. By observing the calculation of the average atomic mass, students can gain a deeper understanding of the principles of isotopic mixtures and the importance of relative abundance in determining the average atomic mass. The simulation allows students to compare their mixtures of isotopes to actual isotopic compositions. By comparing their mixtures to the actual isotopic compositions of elements, students can observe how the relative abundance of isotopes in nature affects the average atomic mass of the elements. This feature helps students understand the relationship between isotopic composition and average atomic mass in real-world contexts. The simulation provides an interactive platform where students can actively engage with the concepts of isotopes, atomic mass, and average atomic mass. By building isotopes, creating mixtures, and adjusting the relative abundance of isotopes, students can gain a deeper understanding of the principles governing isotopes and their mixtures. The visual nature of the simulation makes abstract concepts more tangible. Students can observe the atomic mass, mass number, and relative abundance of isotopes in real time, helping them to grasp complex ideas more easily. The simulation offers immediate feedback, allowing students to see the results of their adjustments instantly. This helps correct misunderstandings quickly and reinforces learning through trial and error. The Isotopes and Atomic Mass Simulation is a valuable tool for teaching and learning about the principles of isotopes, atomic mass, and the calculation of average atomic mass. By providing an interactive, visual, and comprehensive platform, it helps students understand how to build isotopes, investigate their atomic mass, mass number, and relative abundance, create mixtures of isotopes, and compare their mixtures to actual isotopic compositions. Whether used in a classroom setting or for individual study, this simulation can significantly enhance the learning experience and build a strong foundation in chemistry. Through exploration and experimentation, students can gain a deeper appreciation for the complex and fascinating world of isotopes and their applications in various scientific and engineering fields.